Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, as been promised to all of you, I will discuss on the start and Garton analysis, which from previous online class, all of you has answered given question incorrectly. So, from this slide, what is the important thing to know, to remember is to know the each notation and the unit from the equation 1.0. For example, V in this equation is for the voltage applied in volt, and then the denote is the initial thickness in meter, G is the reduced thickness in meter, and Y is the Young modulus of the material given in nano per meter square. Epsilon R and epsilon naught is the relative permittivity and the permittivity of space. So, when the question is given, for example, the denote in centimeter, you need to convert it to the meter. So, rearrange the equation 1.0 just now. We get the equation 1.1 like this. So, this is the important equation to answer the given question in start Garton analysis. Sometimes in the question you are not given directly this equation, so you are given the 1.0 equation just now, and then you need to rearrange by yourself. So make sure you know how to rearrange the equation. So this is the question given in the free online class last 2 weeks. I cannot remember. So this is also from the free online class. Question 3 also from the online class, except that question 4 is given, or is a new question I give in this video. So out of 4 question, I will explain on the question 2, so that you can use it as reference to answer another questions. So let we read the question. So a ceramic insulation sample with thickness of 0.03 meter is placed between electrodes to study the electromechanical breakdown. The thickness of the sample is reduced by 10%, 20%, and 30% each hour after applying a certain voltage magnitude in 3 hours. Given that relative permittivity epsilon R of ceramic insulation is 3.7 and the constant Young modulus is 181 kN per meter square, analyze the applied voltage Vs that caused the deformation for each hour using start Garton model. So most of you missing the word each hour. So when the question said that each hour, so meaning that you need to find the Vs when the sample is reduced at the 10 hours for the first hour, 10% at the first hours, 20% at the second hours, and 30% at the third hours. Okay, so this is the question just now we have read. So the important equation we need to know is this. So what to do when we have this kind of question? First is to extract the data. So from the question we know that it is given that Young modulus is 181 times 10 power 3 because kilo. So and then given that epsilon R is 3.7 and denote initial value is 0.03 meter. So now what to do is find the sample reduced by 10% at the first hours. So by using D at the first hours, so we calculate it. So the initial thickness minus the 10% of the initial thickness, and we get the 0.027 meter. So when we get the reduced sample, so we insert it in the question, in the equation correctly. Bear in mind, D naught is the initial thickness, D is the reduced thickness. So we know that from the first hour, the reduced thickness is 0.027. So 0.027 at D at the front, in front, and also at the lawn. So usually students get confused about this too. So sometimes they change the position. So make sure you remember it carefully. And then after you calculate the first hours, and then you need to calculate another second hours, and so calculate it. So same thing, the initial, still use the initial thickness minus the 20%, reduce, and you got the answers, and then you find the VS, the applied voltage. Then repeat for the third hours, then you got like that. So how the mark is given? So we see that when you extract the data, you are given 1 mark, and when you find the sample radius, you are given 1 mark, and when you calculate or you insert it correctly, 1 mark, and your answer is correctly 1 mark. So total 2 marks. So same. So total you have 10 marks. So okay guys, that's all from me. So you need to submit your individual correction on Thursday, 9 April 2020 before 5 p.m. Answer question 1, 3 and 4 in your beautiful handwriting, and upload your answer in JPEG or Word here at the given platform. Okay, thank you. See you around guys. Take care.